a research and policy-informed discussion focused on the cross-curricular issues within science and mathematics by Katie Elizabeth Mason. Carr 2007 and Zinniak 2007 highlight that cross-curricular learning is also defined as integrated learning, thematic work and project-based learning, therefore implying that skills and knowledge within different subjects are interconnected. As Kelly and Stead 2013 state, cross-curricular approaches are when subjects are linked together within one lesson. With this in mind, the purpose of cross-curricular teaching is to draw on similarities between different subjects in terms of subject content, pedagogical policies and learning processes, and make these links explicit in various ways. As Savage 2011 explains, teachers should motivate and encourage pupils' learning in a sympathetic way in conjunction with their wider life experiences. This can be implemented by providing active and experiential learning for pupils based on individual subjects and their connections through authentic links. Teaching strategies are constantly changing, and cross-curricular work within the primary curriculum has been subject to debate for some time. However, the Plowden report in 1967 insisted that knowledge does not fall into neatly separate compartments. The report concluded that children can apply their knowledge from one subject to another subject, and this can reinforce their understanding. However, it is of importance to mention that the report did recognise that some discrete subject teaching will be relevant for older primary school children. Despite this argument, the national curriculum in 1987 focused on teaching subjects discretely. As a result, this limited the opportunities for teachers to be imaginative and innovative in their curriculum planning, therefore making project-based and integrated learning very difficult to implement. Teaching discrete subjects was further encouraged by successive governments following the Three Wise Men report by Alexander, Rose and Woodhead in 1992, which criticised poorly planned thematic work in primary schools. However, one could argue that when project-based work is planned well, it could produce work of a high standard. The insinuation here is that discrete teaching can be easier for a teacher to plan and identify progress pupils are making. Although teaching subjects discretely seemed to remain as a primary importance in the late 1980s, is by no means proposing that cross-curricular approaches were not implemented during that time frame. As Boyle and Bragg 2008 bring to light, schools reintroduced cross-curricular teaching to enable them to meet expectations outlined in the national curriculum in 1999. As this document stated, children are entitled to a broad and balanced education. The Rose Review in 2009 complements this idea. The review highlighted that skills are learned both through specialist subject teaching and also through rich cross-curricular studies, leading to the superstition that a cross-curricular approach alongside specialist teaching embeds a broad and balanced curriculum. The Importance of Teaching document in 2010 placed emphasis on the new national curriculum, having a greater focus on subject content and more freedom for teachers to promote pupils' cognitive, personal and social development in an integrated way. There are many advantages to cross-curricular teaching and learning. Haynes 2010 recognised that knowledge and skills in one subject are reinforced to support skills in another subject. In view of Haynes' perspective, it would seem that a cross-curricular approach helps children to identify that knowledge and skills can be transferred to another subject. To develop this ideology further, Driscoll et al. 2012 stated that cross-curricular approaches give greater depth and balance to learning instead of using a narrowed approach. This implies that cross-curricular teaching opens up a breadth of experiences that will make the learning more relevant to the child. Rose 2009 complements this idea, as the review found that high standards of subject knowledge are best secured when skills are learned through both discrete and cross-curricular teaching. On the contrary, Alexandra et al. 1992 identified that poor links between too many subjects means little progression is made. Therefore, it is important to take planning into careful consideration. A well-planned lesson is crucial for the success of a cross-curricular approach. Yet, it takes time to plan a lesson well, as Ofsted 2008, Jarvis 2009 and Thomas 2012 highlighted. Cross-curricular work is very time-consuming. Therefore, teachers must make time to plan and prepare lessons in order for pupils to develop the required subject-specific skills and so that they can apply these skills in a different context. Regrettably, research has suggested that lessons may lack rigour and pupils may not develop the required subject-specific skills. This could result in pupils finding it difficult to apply their skills in different contexts. Another adverse factor regarding the implementation of a cross-curricular approach is that teachers may lack confidence in their ability to teach lessons that involves integrated learning. This may be because there has been a lack of training, or perhaps teachers may try and overload the child with too much information in one lesson, resulting in fragmented learning. A theoretical stance, such as Feezy's 1999, suggests that at the heart of science is mathematics. In support of this, Hiscock 2012 stated, "The way that teachers approach science and mathematics can greatly influence their relationship." She also noted that mathematics skills can be applied to science and that the two subjects should be interrelated to consolidate children's skills in different contexts. As you can see, the slide depicts the links between the two subjects, including number, inquiry, problem solving, data handling, reasoning, measurement, statistics, and presenting data. I am going to discuss the role measurement has within mathematics and science. In the 2014 National Curriculum, it has been identified that measurements have a key role within mathematics and science, and bringing maths and science together is beneficial as it allows children to apply their knowledge in different contexts. In support of this, Boss et al. 2010 discovered that science and mathematics use similar terminology and that pupils should transfer their knowledge across the different subjects to consolidate their learning. The curriculum also acknowledges that children should be using simple measurements in Key Stage 1, and when they are in Key Stage 2, there is an emphasis on the accuracy of measurement, resulting in more complex activities. My lesson plan for a Year 6 class. Before planning this lesson, I had a discussion with the class teacher in relation to the children's prior learning, and it was evident that they struggled to measure volume within their science lesson. Due to the maths topic focusing on measuring and converting units, I decided to develop challenge cards for the children. Each challenge card had a measurement that they had to use when they were measuring the length, weight and volume. This encouraged children to use appropriate terminology that are used in both mathematics and science, such as millimetres, litres, centimetres, metres, kilometres and kilograms. On one of the challenge cards, I specifically made sure every child had to measure the volume of liquid, and I gave the measurement to ensure children could concentrate on the accuracy of the measurement before moving on to more complex activities, such as measuring 2 litres of liquid using a 20 millilitre jug. This is where children's problem-solving techniques were being transferred. This lesson has been successful in terms of pupil progress, and I will definitely use this practical solution to integrate maths and science within the classroom in my future teaching. To support the integration of maths and science, Kerry 2011 argued that individual subject disciplines only give a part of a particular topic or problem, and that to enable them to fully understand the problem, children need to be encouraged to draw together insights from different subjects. Within the 2014 National Curriculum, it was acknowledged that pupils need to apply their mathematical knowledge to their understanding of science, including collecting, presenting and analysing data. Here are a few examples of presenting data and how this links to maths and science, as well as incorporating the use of ICT. Information from scientific investigations can be presented in a variety of ways. The most common form of presentation are tables, graphs and charts. Tables can be used to collect and display data for different purposes, and ICT can play an important role and contribute to the pupils' learning when teachers employ excellent pedagogic principles in relation to using ICT. However, if the teacher lacks knowledge with regards to utilising ICT tools, then this could hinder children's learning. For example, software such as Microsoft Excel can be used to construct a graph, but the children must be taught to put the units in the column header rather than in each cell. Graphs are used to provide a pictorial representation. Pictograms and bar charts are a pictorial, and they are used when the independent variable is categorical. Pie charts are pictorial, and they are used to represent proportions of a whole. It gives a representation of one quantity in relation to others. In school this week, children in Year 6 were interpreting data from pie charts within their mathematics lesson as part of the mean, median, mode and range topic. Pie charts are useful when interpreting data, but much to my dismay, it was a very time-consuming process when the children had to draw a pie chart in relation to the data that they had collected. Having said that, children applied their problem-solving skills to identify which graph was appropriate to represent their data. Line graphs, scatter graphs and histograms are also examples of pictorial representations. To further engage children with using ICT, they could use data handling methods and collect the data for themselves. For instance, by using data loggers, they can gather information quickly and spend more time on interpreting the data and drawing conclusions. As well as interactive whiteboards can facilitate learning as a visual tool, as well as supporting teachers so that children are able to interact and discuss ideas using technology to support them. Briggs and Pritchard 2002 reiterate that the use of ICT in primary curriculum can enhance children's learning and improve their academic performance. In conclusion, adopting both a theoretical stance and collated research from organisations has suggested there is an essential link between the subjects science and mathematics, and cross-curricular approaches are increasingly being implemented within primary school lessons. It is crucial that science and maths are taught following the national curriculum guidelines, as integrating the subject aims will make the learning more relevant to the learner. Wider implications have unveiled the time-consuming constraints that are put upon teachers during the planning process. However, the rewards that children and teachers alike can gain from a cross-curricular approach can outweigh the disadvantages. Another potential implication is the lack of knowledge teachers possess with regards to teaching thematic work and utilising ICT skills. On reflection, it would seem that teachers must endeavour to develop their subject knowledge in relation to both cross-curricular and ICT skills with a view to supporting children's primary school education. This is a suggestion for future work in the hope that opportunities will be made for teachers to take responsibility of their own learning and actively seek to develop their knowledge through training courses. In my view, this policy-informed discussion depicts reassuring findings about the importance of implementing a cross-curricular approach within primary education. Since the introduction of the new national curriculum, teachers have more freedom to be creative and innovative within their planning, and from this they can instil transferable skills in cross-curricular lessons to consolidate children's learning.